Okay, we want to try to find the inverse Laplace transform of this nasty looking thing. Anytime you have a quadratic in your denominator, the first thing you want to try to do is factor. If it factors, you're going to get exponentials. If it doesn't factor, you're probably going to get some version of sines and cosines. And kind of as a shortcut, if we were to set this denominator equal to 0 and solve it, if we get complex solutions, we would get stuff that looks like this, exponentials times sines or cosines. If we get real solutions that have radicals in them, stuff like 5 plus or minus root 13, then we'll get sinh and cosh. So we're going to complete the square in this denominator and make it turn into one of these two things, depending on how big this c term is, whether we end up with a plus or a minus there. If it's a plus, we get one of these guys. If it's a minus, we get one of these. We're just looking at a Laplace table here and trying to match one of these forms. Okay, we're going to end up with these two. I know because I've already solved it. So we're going to take that denominator and complete the square in it, meaning we're going to look at that middle term, that 10s. We want half of that squared. So half of 10 is 5. Squared would be 25. Now I'm not allowed to change the problem. So if I'm going to add in 25, the easiest way to do that is add it and subtract it. So we're not actually changing anything. So these two are equal. But now I'm going to group these three together. That's a perfect square trinomial. These three factor s plus 5 squared. And then, of course, negative 25 plus 12 would be negative 13. So I'm thinking in my head that that looks like this one. S minus a squared minus b squared. So that I can match one of these. So I'm matching these two. So my a here is negative 5. And my b is not 13. My b is square root of 13. Because whatever's there is supposed to be b squared. Okay, now we got to do some work. Because I'm supposed to have either s minus a, I need, in this case, an s plus 5. The same thing I have right here on top. I either need an s plus 5 on top, or I just need b on top, root 13. So I have to hammer this guy into some combination of a bunch of these. Okay, so we need, these will give me my cosines, these will give me my sines, times exponentials, sinh and coshes, of course. Okay, so there are a bunch of different ways to do this. We could, for example, factor out this 5 out of everything to begin with and end up with a fraction here, 7/5, and just deal with that. If this had been a 10, that's what I would have done. Then I wouldn't have to deal with the fractions. I would just pull a 5 out of everything and deal with, 5 in front of everything and deal with the 2 here. That wouldn't work here because if we factored a 5 out of the top, we'd get a fraction. So I'm not going to do that here. I am going to split the numerator, though. First guy over the bottom plus the second guy over the bottom. Remember, you can split numerators. You can't split denominators. Okay, let's deal with this guy. So that one has an s in it. I'm trying to make that look like this. That's going to give me, right here, an exponential times a hyperbolic cosine. Okay, so first I'll pull that 5 off the front. That's supposed to say it's right here in the formula. I have to match the formula. Whatever is right here in the parentheses needs to be on top. So I need an s plus 5 on top instead of just an s. So the easiest way to get that is put it in. Put in a plus 5. And to balance that out, I need to put in a minus 5. Now I can split that top up. Grab that s plus 5, split the top. This guy here is exactly what I want. That's an s minus a squared minus b squared. That will give me an exponential times a cosh. This is a number over that same denominator. This will give me an exponential times the sinh. So I went ahead and redistributed that 5. So 5 times 5, that's where the 25 comes from. And then looking ahead, I know if I'm going to use this formula, I need to have my b up here. B was root 13. So to get a root 13 right here, I put one in and in front took it back out. So now I'm multiplying and dividing by root 13. Okay, so this will be my sinh part. This will be my cosh part. Okay, now let's deal with the second part. Remember we had 2 parts. This one's a little easier. I just need that root 13 on top, so I put it in and take it out. Okay, so here's everything put together. This guy, we had those 2 different, this right here gave me these 2 different pieces. This one we just did, it's right there. These 2 here happen to be like terms, so I can combine them together. That's what usually happens on these. In fact, I would make the argument that if your problem looks exactly like ours with different numbers, this will always happen. These 2 will be like terms. All your sinh will squish together. So negative 25 and 7 is negative 18. And now we can do the inverse Laplace transform just using the table. This here, a, remember, was negative 5. B was root 13. So this was that. The 5 comes along for the ride. This constant comes along for the ride. And this was that same exponential times sinh.